So hi students, in last session of Maclaurin series I discussed so many problems and expansion of some functions using Maclaurin's expansion. So in this session also I would like to continue some more interesting problems on Maclaurin's series. As you see one of the problem on Maclaurin series is you have to show that secant x is equal to 1 plus x square by 2 plus 5x to the power 4 by 4 factorial. To prove this result, first to take this function secant x is y. So let y is equal to secant x. Let y is equal to secant x. You take this is the function 1. So now Maclaurin series of the Maclaurin's expansion. Maclaurin's expansion of y of x is y of x is equal to y of 0 plus x into y1 of 0 plus x square by 2 factorial into y2 of 0 plus the series containing, so take this is 2. So now to find y of 0, you put x is equal to 0 in y. So therefore y of 0 value is equal to secant 0 is 1. So now you differentiate this with respect to x. Differentiation of y is y1. Differentiation of secant x is secant x into tan x. So from this you find y1 of 0. y1 of 0 is equal to secant 0 into tan 0. All of you know that tan 0 is 0. So 0 into anything becomes 0. So to find y2 you differentiate y1 with respect to x. Again you differentiate this with respect to x. Differentiation of y1 is y2. Differentiation of secant x, okay, keep secant x as it is. Differentiation of tan x is secant square x plus differentiation of secant x is secant x tan x into tan x. You keep the tan x as it is. Okay, so by using product rule. So now y2 is equal to secant cube x plus secant x into tan square x. Here you write this tan square x is, what is the formula for tan square x? Tan square x can be written as secant square x minus 1 by using trigonometric identity. Tan square x is equal to secant square x minus 1. As here I am writing this tan in terms of secant, because if you write all the terms in terms of secant x, okay, it is secant cube x into secant cube x minus secant x, which is equal to 2 into secant cube x minus secant x, as we expressed all in terms of secant x, because if it is in terms of secant x, then we can replace secant x by y, because y is equal to secant x. So in the given function y is equal to secant x, as we are replacing y by secant x because it helps to differentiate further. Okay, so it is 2 into y cube minus y. From this you find the value of y2. y2 of 0 is equal to 2 into y of 0 cube minus y of 0, which is equal to 2 into y of 0 is 1 minus 1, which is equal to 1. y2 of 0 is 1. Again, to find y3 you differentiate this y2. Differentiate this y2 with respect to x. Differentiation of y2 is y3. y3 is equal to 2 into differentiation of y cube is 3y square. This is the differentiation of its power. Again, differentiation of y with respect to x is dy by dx. We write that dy by dx is y1 minus differentiation of y is y1, which is equal to 3 2s are 6 y square into y1 minus y1. As from this you find y3 of 0, therefore y3 of 0 is equal to 6 into y of 0 square into y1 of 0 minus y1 of 0. Yes, both the terms consists of y1 of 0, the value of y1 of 0 is 0, so y3 is completely 0. Again you differentiate this y3, so to find y4, so differentiate with respect to x, its differentiation gives that y4 is equal to 6 into differentiation of y square is 2y into y1 and y1 already ಇರೋದು ಇದು y1 ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಆಫ್ y ಸ್ಕ್ವೇರ್ ಏನಾಗುತ್ತೆ ಅಂದರೆ 2y ಆಗುತ್ತೆ ಮತ್ತೆ ಇದ್ರ ಪವರ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ 2y ಮತ್ತೆ y ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಿದ್ರೆ y1 ಬರುತ್ತೆ. So and this y1 constant, you can write constant y1 as it is, plus in next step you write 6y square as it is, differentiation of y1 is y2 minus differentiation of y1 is y2. So from this you find, okay, simplifying this first, 6 2s are 12, 12y into y1 square plus 6y square into y2 minus y2. Therefore y4 of 0 is equal to, y4 of 0 is equal to 12 into y of 0 y1 of 0 square plus 6 into y of 0 square y2 of 0 minus y2 of 0, which is equal to, you know that y1 of 0 value is 0 plus 6 into y of 0 andre 1, y2 of 0 is 1, 1 square means it is 1 only, minus y2 of 0, that is 1, it is 6 minus 1 is equal to 5. Substituting all these values, substituting these values, all these values in the expression 2, so we get that y of x is equal to, so y of 0 value it is 1 plus x into y1 of 0 it is 0 plus x square by 2 factorial into y2 of 0 andre that is 1 plus y3 value is 0 plus x to the power 4 by 4 factorial into y4 of 0 is 5 plus that series continuing like this. Y of x is secant x, so secant x is equal to 1 plus x square by 2 factorial plus 5 into x to the power 4 by 4 factorial plus and so on. This is the value of secant x. So secant x in power series, value of secant x in power series. From this we can find what is its application if you wanted to find the secant 0 value. So by if you know that secant 0 value is 1, so instead of, okay, just put x is equal to 0 here, in right hand side all x becomes 0, what is the value remaining? It is 1 only. So like this you can find any value of secant, so by using this power series without finding its value in trigonometric form. So okay, directly by using this power series we can find its value. So like this we can find the any value of secant. As one more problem on Maclaurin series is, so obtained by Maclaurin's expansion, of tan inverse of x. We need to find tan inverse of x in power series by using Maclaurin's expansion. So let y is equal to tan inverse of x. First to take the function y is equal to tan inverse of x. Y is equal to tan inverse of x. Okay. So now you take Maclaurin's expansion of y. Maclaurin's expansion of y is y of x is equal to y of 0 plus x into y1 of 0 plus x square by 2 factorial into y2 of 0 plus and so on. You take this is a 1 and you take this expression is 2. Yes, now you take y and you just differentiate that. Y is equal to tan inverse of x. So differentiate this with respect to x. Differentiation of y is y1. y1 is equal to 1 by 1 plus x square. Differentiation of y1 is equal to 1 by 1 plus x square. So therefore from this you find the value of y1 of 0 by taking x0 here. y1 of 0 is equal to 1 by 1 plus 0. ಇಲ್ಲಿ x ಅಲ್ಲಿಗೆ 0 ಹಾಕಿ 0 ಹಾಕಿದ್ರೆ ನಮಗೆ y1 of 0 ಬರುತ್ತೆ. That is its value is 1. y1 of 0 is equal to 1. Now next step you write y2. So we can easily find y2 also. But so instead of doing like this, better you apply nth differentiation for this. So if you apply nth differentiation once, from that you can find the differentiation of y of any order. So y2 y3 y4, you can find any differentiation of y with any order by taking its nth differentiation. So to apply the nth differentiation for this, you take like this 1 plus x square into y1 is equal to, sorry, it is not 0, it is 1. Its value is 1, so it is 1. So 1 plus x square into y1 is equal to 1. Apply nth differentiation for this. So if you are applying nth differentiation, it gives that yn minus 1 yn minus 1 ಕೂಡ ಬರುತ್ತೆ. yn plus 1 yn plus 1 yn and yn minus 1 we are getting. So then it is not a problem. Okay, so take its nth differentiation, apply nth differentiation, apply nth differentiation for this. So then it is nth differentiation of 1 plus x square into y1 is equal to nth differentiation of 1. 1 is a constant, that first differentiation of 1 itself becomes 0. Okay, so that right hand side is 0. To apply the nth differentiation for this, it is very easy method to apply nth differentiation. The thing is here you take 1 plus x square. So here I am using Leibniz theorem. Okay, so 1 plus x square you write as it is. So for this 1 you add n, so it is n plus 1. So after writing this first step, second step is easy. So actually we have to write NC1 value is n, so write n as it is. So write n first and you differentiate this 1 plus x square, it is 2x. Actually I am using the Leibniz theorem here. So you in previous classes you studied Leibniz theorem and other concepts of finding its nth differentiation. I am using that same here. So reduce one number from yn plus 1. ಇದರಲ್ಲಿ one number ಕಡಿಮೆ ಮಾಡಿ yn plus 1 ಅಲ್ಲಿ. So then it is yn. In next step it is nc2, that is n into n minus 1 by 2. And you differentiate this to x, its value is 2. And reduce one number from this, so it is yn minus 1. ಇಲ್ಲಿ n plus 1 ಇದೆ, 1 ಕಡಿಮೆ ಮಾಡಿ n ಆಗುತ್ತೆ, ಇನ್ನೂ 1 ಕಡಿಮೆ ಮಾಡಿದ್ರೆ n minus 1 ಆಗುತ್ತೆ. ಸೊ ಹಾಗೇನೆ ಇಲ್ಲಿ 1 ಇರುತ್ತೆ, n ಇರುತ್ತೆ, n into n minus 1 by 2 ಬರುತ್ತೆ. ಹಾಗೆ ಫಸ್ಟ್ 1 plus x square ಇರುತ್ತೆ, ಅದರ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮತ್ತೆ ಅದರ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್. ಸೊ ದಟ್ ಈಸ್ ದ ಪ್ರೊಸೀಜರ್ ಆಫ್ ಅಪ್ಲೈಯಿಂಗ್ ದ Leibniz theorem here. So which is equal to right hand side is completely 0. So now this is yn 1 plus x square 1 plus x square into yn plus 1. This is what? Plus 2nx into yn. Here you can cancel this 2 and 2. Plus n into n minus 1 into yn minus 1 is equal to 0. ಇದರಲ್ಲಿ ಏನು ಮಾಡಿ ಅಂದರೆ put x is equal to 0 ತಗೊಳ್ಳಿ. ಇದರಲ್ಲಿ just take x is equal to 0. Put x is equal to 0 in the above expression. So which implies that, so then it becomes yn plus 1 of 0. If you put x is 0, the second term is 0. ಇಲ್ಲಿ ಏನಾಯಿತು 1 plus 0, 1 plus 0 square means that is 1. 1 into yn plus 1, yn plus 1 of 0. If you put x is 0, this term completely becomes 0. Plus this is n into n minus 1 into yn minus 1 of 0. yn minus 1 of 0 is equal to 0. So that is yn plus 1 of 0 is equal to, take this term to right hand side. ಅದು right hand side ತಗೊಂಡ್ರೆ n into n minus 1 into yn minus 1 of 0 ಆಗುತ್ತೆ. So now we can easily find nth differentiation of any order. ಈಗ for example ನಮಗೆ ಆಲ್ರೆಡಿ y1 ಬಂದಿದೆ. If you wanted to find y2, right? We already find the value of y1 0, y of 0. y of 0 find ಮಾಡಿಲ್ಲಲ್ಲ. So you can find the value of y of 0. y of 0 is what? y of 0 is equal to tan inverse of 0. Tan inverse of 0 is 0. So similarly, to find y2 of 0, you just take n is equal to 1 here. To find y2 ಬೇಕಂದ್ರೆ n 1 ಹಾಕೊಡಿ ಅಷ್ಟೇ. Put n is equal to 1, which implies that y1 plus 1 of 0 is equal to, if you put n is equal to 1 here, 1 minus 1 ಬರುತ್ತೆ ಇಲ್ಲಿ, minus 1 into 1 minus 1 into y0 of 0, which is equal to 0 because 1 minus 1 is 0. 1 minus 1 becomes 0. So to find y3, take n is equal to 2, which implies that y2 plus 1 is 3. y3 of 0 is equal to minus 2 into 2 minus 1 into y2 minus 1 is y1 of 0, which is equal to minus 2 into 1 into y1 of 0. Where is the value of y1 of 0? ಅವಾಗಲೇ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ದೀವಿ y1 of 0. We find that y1 of 0 is 1. You substitute that same here. y1 of 0 ಅಂದರೆ 1 ಇದೆ, 1 ಹಾಕಿ. So then it gives that minus 2. The value of y3 of 0 is minus 2. Yes. To find y4, you take n is equal to 4. Put n is equal to 4. Sorry, n is equal to 3. If n is 3, then it is y2, 3 plus 1 is 4. y4 of 0 is equal to minus 3 into minus 3 into this is minus 3 into 3 minus 1. 3 into 3 minus 1 into y3 minus 1 is to y2 of 0, which is equal to minus 3 into 2 into y2 of 0 is. So you know that y2 of 0, ಅವಾಗಲೇ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ದೀವಿ ಇಲ್ಲಿದೆ. So this is y2 of 0 value is 0. You just take it is 0. So it is 0 only. Take n is equal to 5, which implies that y5 of 0, ಇಲ್ಲಿ nಗೆ ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅಲ್ಲಿ nಗೆ 5 ಹಾಕಿದ್ರೆ, ಸೊ nಗೆ 3 ಹಾಕಬೇಕು. ಆ್ಯಕ್ಚುಲಿ ಇಟ್ ಇಸ್ ನಾಟ್, ಸಾರಿ 4 ಹಾಕಬೇಕು, nಗೆ 4 ಹಾಕಬೇಕು. ಸೊ ಜಸ್ಟ್ ಪುಟ್ n is equal to 4 ಹಿಯರ್. ಸೊ nಗೆ 4 ಹಾಕಿದ್ರೆ, ಸೊ ಇಫ್ ಯು ಪುಟ್ n is equal to 4, nಗೆ 4 ಹಾಕಿದ್ರೆ y5 ಬರುತ್ತೆ. y5 of 0 is equal to minus 4 into 4 minus 1 into y. n ಗೆ 4 ಹಾಕಿದ್ರೆ ಇದರಲ್ಲೇ 4 minus 1 ಅಂದರೆ 3, y3 of 0, which is equal to minus 4 into 3 into y3 of 0 is minus 2. So ಏನಾಯ್ತು ಇದು? So this is nothing but 4 3s are 12, 12 2s are 24 plus 24 ಆಯಿತು. So using all these values in 1, so ಇದೆಲ್ಲ ತಗೊಂಡ್ಬಂದು ಈಕ್ವೇಶನ್ 1ಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ, substitute all these values in 1, substituting in 1, substituting above values in equation 2, sorry, it is equation 2, substituting all these values in equation 2 ಗೆ substitute ಮಾಡಿದ್ರೆ, so it gives tan inverse of x. So tan inverse of x is equal to, you obtain tan inverse of x because y is tan inverse of x. Tan inverse of x is equal to y of 0 ಅಂದರೆ 0 plus x into y1 of 0 ಅಂದರೆ 1 plus y2 of 0 ಅಂದರೆ 0 plus x cube by 3 factorial into y3 ಅಂದರೆ that is minus 2, y3 is minus 2 plus x to the power 4 is 0 because y4 of 0 is 0 plus x to the power 5 by 5 factorial plus x to the power 5 by 5 factorial into 24. So tan inverse of x is equal to, tan inverse of x is equal to, it is x minus 2 into x cube by 3 factorial, 3 factorial is 6 and plus 24 into x to the power 5 by 5 factorial is 120 minus and so on. So if you simplify this, it gives that x minus x cube by 6, 2 by 6 is 3 plus x to the power 5 by 24 ಇಂದ 120 ನ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ it gives 5. x to the power 5 by 5 minus, similarly you get x to the power 7 by 7 plus x to the power 9 by 9, like that it continues. So this is the expansion of tan inverse of x by using Maclaurin's series. So obtain this by using Maclaurin series. Similarly, here you see this e to the power of x into cos x up to x to the power 4th term by Maclaurin's expansion. So first we consider this function is y. Let y is equal to e to the power of x into cos x. Take this is 1. Maclaurin's expansion of y of x is, you know that y of x is equal to y of 0 plus x into y1 of 0 plus x square by 2 factorial into y2 of 0. It continues like this. Okay, so first to take y is equal to e to the power of x cos x. From this you find y of 0. Y of 0 is equal to e to the 0 into cos 0. E to the 0 is 1, cos 0 is 1, 1 into 1 is 1. So now from this you can easily find its nth. If we write its nth derivative, then we can write its corresponding y1, y2, y3 from that nth differentiation. So that is the one option. And another option is you just go and differentiate this y. ಅದು ಏನು ಬರುತ್ತೆ, ಒಂದು ಸ್ಟೆಪ್ಪಲ್ಲಿ ಎರಡು ಟರ್ಮ್ಸ್ ಬರುತ್ತೆ ಫಸ್ಟ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನಲ್ಲಿ. ನೆಕ್ಸ್ಟ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನಲ್ಲಿ ಅದು 3 ಆಗ್ಬೋದು, ನೆಕ್ಸ್ಟ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನಲ್ಲಿ 4 ಆಗ್ಬೋದು. ನೀವು ಅಪ್ ಟು 4 ಬೇಕು ಅಂದರೆ So it takes its 4-5 steps first ಬರುತ್ತೆ. But instead of that, if you write the nth differentiation, you know that nth differentiation of e to the power of x cos bx is equal to, so a square plus b square to the power n by 2 into e to the power of ax into cos n tan inverse of b by a, n tan inverse of b by a plus bx. This is the formula to find. It is the standard formula of nth differentiation of e to the power of ax into cos bx. Similarly ನೀವು ಅದನ್ನೇ ಅಪ್ಲೈ ಮಾಡಿಕೊಂಡ್ರೆ yn ಬರುತ್ತೆ ನಮಗೆ. yn is equal to nth differentiation of e to the x into cos x. Here a and b values are 1, so therefore yn is equal to 1 square plus 1 square to the power n by 2 into e to the power of 1x into cos n tan inverse of 1 by 1 plus x. So that is yn is equal to 1 plus 1 is 2 to the power n by 2 into e to the power of x cos n tan inverse of 1. Tan inverse of 1 is pi by 4 plus x. So this is yn. You take yn of 0. Yn of 0 means you put x is equal to 0. So then it is 2 to the power n by 2 into e to the power 0 into cos n pi by 4 plus x is 0. So now it is yn of 0 is equal to, this is 2 to the power n by 2, e power 0 is 1, cos of n pi by 4. From this you find y2 of 0, y1 of 0, y3 of 0, all those values. So put n is equal to 1. So when n is equal to 1, which implies that y1 of 0 is equal to 2 to the power 1 by 2 into cos 1 into pi by 4. So 2 to the power 1 by 2 is square root of 2. Cos pi by 4 value is 1 by root 2. So root 2 cancels, which gives 1. Similarly, when n is equal to 2, which implies that y2 of 0 is equal to 2 to the power 2 by 2 into cos of 2 into pi by 4. So 2 1s are 2 2s are cos 90. Cos 90 value is 0. So when n is equal to 3, which implies that y3 of 0 is equal to 2 to the power 3 by 2 into cos of 3 pi by 4. Cos 3 pi by 4 means it is 135 degree. 135 degree. So you can write it is, of course its value is minus 1, direct agi baribodu. So if you are not understanding, you may write like this. This 2 to the power 3 by 2 can be written as 2 into 2 to the power 1 by 2 into cos 180 minus pi by 4. 180 minus pi by 4 is 3 pi by 4. So here you can use ASTC rule. So 180 minus means second quadrant. In second quadrant cos is negative. So it is 2 into 2 to the power of 1 by 2 is root 2. Cos 180 minus theta is minus cos theta. Minus cos pi by 4. So that is minus 2 root 2 into cos pi by 4 is 1 by root 2. Root 2 cancels. So its value is minus 2. y3 of 0 value is minus 2. Similarly, you try to find y4 of 0. Actually, how many terms we need to find? X to the power 4. So we need to find y4 of 0. It's enough. So when n is equal to 4, which implies that y4 of 0 is equal to 2 to the power 4 by 2 into cos of 4 into pi by 4. 4 cancels. Here 2 ones are 2 twos are. Remaining is 2 square here. 2 square into cos pi. 2 square is 4. 4 into cos pi. Cos pi value is minus 1, which is equal to 4 into minus 1 is minus 4. So now you substitute all these values in the given expression. 2 equation 2 ಗೆ substitute ಮಾಡಿದ್ರೆ ಇದೆಲ್ಲ ತಗೊಂಡು ಬಂದು, so now 2 becomes, now expression 2 is, now 2 becomes, so y of x is e to the power of x into cos x is equal to y of 0 1 plus x into y1 of 0. Yes, you see y1 of 0 is 1 plus x square by 2 factorial into y2 of 0. y2 of 0 is 0. y2 of 0 is 0 plus x to the power 3 by 3 factorial into y3 of 0 is minus 2 plus x to the power 4 by 4 factorial into x to the power 4 by 4 factorial into, so y4 of 0 is minus 4, it is minus 4 and so on. So that is equal to, it is 1 plus x, y2 is 0, this term becomes 0, minus 2 into x cube by 3 factorial is 6, minus 4 into x to the power 4 by 4 factorial is 24, plus and so on, which is equal to 1 plus x minus x cube by 2 ones are 2 threes are 6, 2 threes are 6. Similarly, this is minus x to the power 4 divided by, if we divide this 24 from 4, it gives 6. So plus, this series continue like this. This is the expansion of e power x cos x by using Maclaurin's expansion. Okay. So try to solve this problem. Expand log of x plus root of x 1 plus x square up to the 4 terms by Maclaurin's expansion, and after that if you put x is equal to 0.75, then this value becomes 2. So from that you can find the value of log 2. You try to find its up to 4 decimal places, and again, so try to expand the log of 1 plus e to the power of x up to 4 terms of Maclaurin's expansion. Okay, that's it. So try to find these two values. So after this Maclaurin's expansion, so one more topic is there, that is the indeterminate forms. So in that one you discuss what is indeterminate forms, so and other concepts. Thank you.